Welcome to Study Loop.
In this problem, we have been given that there is a fan and this fan here is turned off and it was initially running at the angular velocity of 850 revolutions per minute. So let's take this as omega naught to indicate that this is the initial angular velocity. So converting it into radians per second, we multiply 850 with 2 pi and divide it with 60. That gives us 88.97 radians per second. And this cooling fan turns 1250 revolutions before it comes to a complete stop. So when it comes to complete stop, final angular velocity will be 0 radians per second, and the angle traced or the angular displacement in this process will be 1250 times 2 pi radians. And we need to determine first the angular acceleration of this cooling fan. So let's say angular acceleration is represented by omega, this alpha here, and we can use the kinematic equation 2 alpha theta equals omega square minus omega naught square. So rearranging gives us the value of angular acceleration as minus 88.97 square divided by 2 times of theta. So theta we can simplify, that will be 2500 into pi. That's 3.14. So simplifying this, we're going to get here the angular acceleration as 0.5 radians per second square approximately. And of course, it will be in negative values because the negative values just indicates that due to this retarding angular acceleration, the fan will be able to come to a complete stop. Now in the next situation, we have to figure out the time that this fan takes to stop. To get the time, we're going to make use of the equation omega equals omega naught plus alpha t. So omega is 0, omega naught is 1250 into 2 pi, alpha is minus zero point 0.5 and t. So from here we can figure out the time, so that will be 2500 into 2 pi. So this gives us the value of the time as 7850 seconds.